Hello, today we're going to talk about function notation and how to write and solve expressions in function notation. So here I've got a function y is equal to 2x minus 5. I know that if I sketch this, this would look like a line. I know that from my grade 9 math classes because that's all we covered. But if I asked you to find y when x is equal to 4, you know what to do. You would just replace every single x that you see with 4 and you would solve for y. So if you were to replace the x with 4, you would get 2 times 4 minus 5, and I guess that would be 3. That's fine and dandy, but I don't want to always keep writing find y when x is equal to 4. So an easier way to keep saying that is I can really just find, well, I can tell you to find f of 4. What in the world do I mean by that? Well, in fact, this y here can be written as f of x. And why in the world do we say f of x? Because if you think about functions and what it means to be a function is almost like a function machine where I put some type of an input. My input is all the possible values of x into this function machine, and then I get an output output. So what does that really mean? So if I put in my input for x to be 4 in this case, and my function machine is telling me to find y is equal to 2x minus 5, my output is really y, which is equal to 2 times 4, take away 5, which is equal to 3. So my output is y, my input is x, and this is my function machine. So if this is my function machine, I can really think about y as a function of x, because it will change based on the value that I put in the x. The output is dependent on the input, and the output is the y, or f of x. So let's keep going. So if I write my y as f of x, now I do have to say that f of x does not mean f times x. F of x is not equal to f times x. This is simply the function notation. It really means function of x. And it really just reminds us that y is the output and it depends on the value that I plug in for x. In other terms, I can also call y a dependent variable because it depends on x, and you're going to hear that term a lot, I think, as well. Okay, well, let's go ahead and just rewrite this y as f of x and say that it is equal to 2x minus 5. I now don't have to say find y when x is 4, find y when x is 0. I can really just ask you find f of 0. And that really tells you that you're going to replace x with 0 and solve for y. Now, I can do that with any number. I can ask you to find f of 100. I can also ask you to find f of a plus 1. The method stays the same. F of 100, what I'm going to do is I'm going to replace x with 100 and solve for y. F of a plus 1, guess what I'm going to do? Same thing as I did before. Replace x with a plus 1 and solve for y. Now, of course, if I replace it with a plus 1, I'm going to end up with more letters. Instead, now I'm going to have a as my letter instead of x. But that's fine. It's okay. That's all I wanted you to do. So there it is here, simplified. Of course, I distributed here and then solved or simplified, expanded, and collected like terms. So this is fine and dandy. Now, what I could also ask you is I could give you the same function, and then I can say, hey, find x when y is equal to 4. So what in the world am I asking you here? Find x when y is 4. So, I mean, if I'm just using this expression here, I can really just say, well, 4 is really equal to 2x minus 5. And then I can go about solving for y. And that'll be 9 is equal to 2x, because, of course, I've got the negative 5 over. I'll divide both sides by 2. And I'll end up with 4.5 is equal to x. Of course, I could have left it as a fraction as well. Now, another way of doing this, another way of doing the exact same thing, if I was to use function notation, remember my y, I'm replacing it with f of x. So if I had my equation written in function notation, I could have just asked you to find x if f of x is equal to 4. So when I tell you that f of x is equal to 4, I really mean, well, y is equal to 4. And what's y? F of x. So I'm just going to replace the entire f of x with 4 and solve for solve for x. And this is going to be the same answer that we got on the other side, which is going to be divided by 2. So it's going to be 4.5 is equal to x. Now, one more thing about function notation. Here I'm writing it as f of x, function of x, and that's equal to 2x minus 5. Now, let's say that I wanted to give you a series of equations, and I kind of wanted to make them different. So if I keep writing f of x, well, you're not going to know what f of x is equal to. I can make it x squared plus 4, and look at this. I'm now coming up with f of x for all these different equations. That's not really fair. They're not equal to each other, and in this question, I'm kind of saying that they are. So that's not really okay. So let me go ahead and change them around, and the way we do that is we actually just change this f of x into, well, maybe I can call it g of x. I can call it g of x. I can call it h of x. I'm following the alphabet here. Now, instead of x, I don't even have to use x anymore. Well, how about I use p for x? So I can have 3p plus 1. Well, if I'm using p for x, I'm not going to have f of x. I'm going to have f of p. Now, I don't even have to call it f of p. I can call it g of p, and so on. So people have actually used a ton of different letters instead of just f of x to kind of make the problem more meaningful. For example, if I'm talking about volume of a spherical ball, so if I have this ball or a balloon that's being inflated, let's say, and the volume of the balloon is getting higher and higher because as I'm inflating it, I'm increasing the radius, I would be relating volume and radius. So my function notation would be v of r, because it would be volume as a function of the radius, and then probably it'll be something like 4/3 pi r cubed or something like that. I can't remember my volume of a sphere equation, but I would certainly have v and r in my expression instead of f of x. But it means the exact same thing as f of x. It's just a way for us to be a little more specific in describing what the input and output is. Thanks so much for watching. Talk to you.